I would propose that we wait 2 more minutes to wait for the late participants to join in, and then I will start introducing the workshop. All right, so I guess that's the timer for starting. So good morning, everyone. Well, welcome to this second workshop of Ferry Pact on mapping. The subject of the workshop today is documenting mapping community practice. I would like to start to thank the Task 4.4 team for organizing this workshop, and in particular Nick, Yana, Carol, Sarah, that actually worked hard to put together this workshop. So I will be giving a short intro. If I talk too much, you can actually kick my ass and say, oh, because I talk a lot. My name is Yann Le Franc. For those of you who do not know me, I'm leading the task. And today, we're going to talk about mappings, right? So what we mean with mapping is, well, relations that we create between concepts. So here I like this cat picture because everybody or almost everybody likes cat. I could add dogs as well, but cats works well. Where the idea is that if you have different information systems that use different names for the same thing, at some point when you want to reconcile them or aggregate them or work with this heterogeneous landscape of data systems, well, you need at some point to tell the computer that a domestic cat is the same as Felis silvestris catus in another database or in another information system. You also need at some point to say that cat is domestic animals is also broader than cats, so that you can actually relate things and you can actually search and retrieve the information that has been named differently. So basically, these mappings by themselves, there are ways to tell the computer how to link two different entities and to specify the relation that links them. So we saw just here a meaning or semantic relation that says these are equivalent or same, right? But that can be something completely different where you can have two entities that could be data and you would have a transformation relation that exists between them. Now, these mapping alone are not enough, because if you want to use them and reuse them, and that's also the work that we are doing in this task, is to actually highlight the fact that you need them to be documented, right, with proper metadata so that you can actually understand in which context these mappings have been developed, who did that, for what purpose, and you can then reuse and exploit the mappings done by others, because the mapping process is quite expensive in terms of time and effort. And then you can have, well, many mappings that works together to align at least two different databases, or that could be two different metadata schemas. And then in that situation, then you will talk about mapping sets and crosswalks. Now, the objective of our task in the Fair Impact project is actually to work on these mappings to establish guidelines on how to make them fair. So for instance, the fact that these mappings must be documented with proper metadata is one of the aspects of increasing the fairness of the current mappings. We're also working on trying to propose a machine actionable common exchange model for sharing the diversity of fair mappings. So one of the recommendations that are already presented at the International Data Week and RDA, if you've been there, is use SESAM. There's one very nice model, so use it as much as you can. And we'll try to think and identify the edge cases so we can come up with other recommendations of model for sharing your mappings. The other aspect, which is inherent to the project, because we are coordination and support action, is to engage with the communities to co-create, test, and adopt the models for fair mappings, to identify also the methodologies and practices around mappings. And that's a bit the point of the day. And also, if we're talking about practical methodologies and practices, we need to talk about governance. How do you maintain these mappings over time? How do you update them? Is there any process, and is there a framework for governing these mappings? And this is some work we do in collaboration with Task 4.1. Now, as I mentioned, you see, based on our objective, for me, we are tackling the problem as a mapping is like a coin, and there's two sides. One is what I would call the technical aspect, with model for sharing, metadata for documenting, and so on. There is the other aspect, which is how do you do mappings in practice, right? In your communities, you're certainly doing that for some specific use case. Now, we would like to know how you're doing that and to see whether or not we can come up with a common recipe that could be useful for communities that haven't started the mapping process and that would need some help and guidance in doing so. And that's the point of the workshop today. How we're planning to tackle this issue, we are planning to organize a series of 3 workshops, and that's the first workshop of the series. To actually involve the various communities and try to collect as much information during the workshop, start thinking about, discussing about the process of mapping by itself, see if we can identify common steps that could be applied by any community, and so on and so forth. The other way of doing this is collecting inputs directly also from practitioners through a survey. We are still working on defining the questions and making sure the survey does not take too long to fit in. But the idea is that by the end of the year, we'll advertise for that survey and start asking people to provide us with more information. Our idea as a final output of this series and of that work, so toward the end of the project, is that we should actually have the possibility to share the process as a on the form of a recipe and leverage an existing resource that's called the FAIR Cookbook and the RDM Toolkit to actually share this information toward the communities. So you will hear about the FAIR Cookbook after my presentation to give you a sense of what it is if you don't know the resource, so you can have a look at it. And that also gives us a perspective on where we want to be in the at the end of the next 2 workshops. Now, for this workshop, we want to start by, discussing and identifying different mapping methodologies and process. And we invited communities to actually present their way of dealing with mappings. And then there will be a working session with breakouts where the idea is, based on what we've learned in the first part of the workshop, can we identify common steps in the process or common elements or components that could be shared with communities willing to start their mapping process. In this slide, you see there is the collaborative notes. It's also in the chat, so please do not hesitate to contribute. Add your name and affiliation, and actually also update your, please update your name on the Zoom so that we know who you are and which institution you represent. Now, briefly on the agenda. So, I start with the welcome and introduction, and I'm done already over time. Then we have a presentation from Philippe Rocasera on the FAIR Cookbook, which is to introduce the target goal. Then we have a series of community presentations by different speakers and different communities. And then we'll have a short coffee break. And then we'll move to breakout sessions, and we'll explain you how we are planning to handle the breakout sessions. And there, the objective is to identify these common components. And then we reconvene for 20 minutes to discuss the feedback from the group, summarize the discussions, and see where we can go for the next workshop. And with that, I will stop my presentation, and I would like to give the floor to Philippe for introducing the FAIR Cookbook. Philippe, I think you're muted.
Okay, indeed. I started. Can you see my screen yet?
Yes.
Yes, all good. So, well said. So, thank you very much for the invitation and for providing me the opportunity to present. So I will present rapidly, very quickly, an overview of the Fair Cookbook, which is a huge effort from a big community of people. So I'm presenting on their behalf. The Fair Cookbook is an Elixir resource, which has been developed part of the Fair Plus project, which is an IMI project, which is therefore a public-private partnership with industry and academic partners. Got a list of people. The paper was accepted in Scientific Data, so I included the link to the presentation, to the manuscript. Also highlighting the editorial board that we have organized. This is important information. I wanted to have it up front so that this is the contact people that you can reach if you want to discuss a project of contribution. What we want to aim as part of the sustainability plan afforded by Elixir to some extent is to continue the development of the resource, the content of the Fair Cookbook in the form of recipes, which is what we are building. It should be very hands-on, practical guidance for users. We aim to keep on doing the process that we had, which we had a monthly book dash. Now we have to change the kind of periodicity of this, but we are happy to organize events, content at home, I guess, to finalize and promote and integrate the contribution of the community to the platform. So just a few words on the technical aspects. I mean, the platform itself was chosen because we had discussions with the Turing Institute, which was developing at that time the Turing way of data science. And they were using a platform which is basically a Jupyter Book, which is a mix of Jupyter notebooks, so code, Python code in an IPython framework, and Markdown documents, which are then rendered with a thin layer over things to produce the HTML pages, which are hosted by GitHub. So all our infrastructure is on GitHub, which reduces the cost of hosting, obviously, and this is an aspect of sustainability that is important. And we have completely aligned because we wanted to retain this kind of possibility of compatibility with this effort from the Turing Institute. So that gives a big context about the kind of technical aspects that we are expecting, but we don't want it to be a barrier either. So we are fairly flexible. In a way, we mostly prefer to have Markdown document or Jupyter notebooks because then we can easily integrate that. For Markdown, I think there is a very convenient tool which is called HackMD, which can be easily integrated in a GitHub repository that allows you to have this kind of editor function. You have the Markdown on one pane and the rendering on the other side, which allows you to rapidly see what you do. And you could do that collaboratively, which is a nice feature as well, and then push that to the GitHub repo. We provide I will show you in a moment, also a kind of template for the recipe. So you're not completely lost. We provide a framework that allows you to backbone to identify the key elements, the key sections that you would like to fill in. So in terms of content, owing to the origin of the Fair Cookbook, we have a strong emphasis on life science, but it's mostly also related to pharma and this kind of type of data. So from preclinical and omics, interventional study, these are the contexts that observational studies data that we wanted to document and how to verify them. So you can contribute a number of things. Obviously, for your case, you're mostly interested in contributing how to do mapping. So I think this is addressing an interesting coverage area. We have initial content, documentation about OXO from EBI, but of course, having more insights from how to use SSOM, for instance, and the different techniques is very important for us. So this is the kind of things. And just a few pointers as well about some of the technical aspect that you get for free when you push content to the cookbook. The recipe will be fair itself in a way. You will be given a stable identifier. We ask people to identify their authors using their ORCIDs. we have a schema.org annotation built in the pages, so we can be picked up by the search engines, and all these kind of links are documented clearly in the documentation. So in terms of how to contribute, as I indicated, you can be a Jupyter notebook, it can be a Markdown document, but you don't have to know anything about that either. You could also start writing in a Google Doc and then contact the editorial board, and we will help you, or we will take the content and reshape it and then put it in the cookbook. We will give you the identifier for the recipe and that you can include in your publication as well. So that's the thing. And the best way to do this is to contact the editorial board, the interest that I gave you at the beginning of the presentation. But also what you can do is to open an issue on our tracker, for instance, and just to start discussing the issue. So, you know, what we want to expect in content, these are just to give you a few flavor that kind of things that we've been doing so far, but also where things can be expanded, because as I indicated at the beginning, we were strongly embedded with pharma partners owing to the nature of the IMI project, but we're also now looking at creating communities, and we have been working very successfully with the plant community. So big shout out to Cyril Pommier and colleagues for the contribution they've made to the Fair Cookbook on this front. And this is just to illustrate how we can engage successfully with communities to augment and share the community of practice in a way, and share our experience about these documentation of how to deliver important components around verification processes. In the context of mapping, I mean, it is an important aspect, obviously, because this is what we've been confronted under FAIR+. We identify different verification paths, and each of them, depending on the stage where you place yourself in the development of, in the path of drug development, I would say. You have a number of formats or semantic artifacts that support this particular use case, and there are obviously needs to bridge between these different components when you want to go across in a more translational point of view, from early research data to late phase drug repurposing, pharmacovigilance, for instance, aspects. Because simply the terminology that are used are not necessarily shared properly or common. They use different framework depending on the context. So I think this is where the most important aspect of mapping and bridging this different continent is essential, and will have even more importance in the future. So I will finish really very rapidly now. I just point out to our GitHub repository. As I was mentioning, everything is hosted on GitHub. We have GitHub Actions that are checking and building the tool, the site for every new release. So this is a live resource. The process is handled by the editorial group, and you engage with us via the tracker. As you can see, the pages, and this is one of the best way to interact, so we can discuss the content and the topic you would like to see covered. So I include now the link to the editorial board if you want to reach us, and we would be happy to assist as much as we can. And rapidly, this is a structure of the recipe, an outline. I mentioned that we provide a backbone. We asked most of the time, I think this is a very important aspect, to provide a kind of overview, graphical overview. We use Mermaid for that, which is again an open source Markdown editor that can be easily integrated, but which renders a graphical overview of the overall process. This is, an image is worth 1,000 words, and then we have different steps that we can detail with you and integrate. You don't have necessarily, as I pointed out, need to know absolutely everything about Markdown and GitHub. We can start from a Google Doc or a Word document and work into it for the integration with you. Yes, that's an important aspect. What we do, the curation, as part of the curation, we maintain a number of links, mainly with another Elixir core resource, which is the RDM kit. And we are reaching to the Pistoia Alliance, but also fair sharing sites, because there are contents and link outs. It's always interesting to see the kind of additional insert ourselves in the landscape of fair efforts. I will briefly mention also the important aspect, which is the kind of maturity level that we tag for each of the recipe. This is an indication of where in fair applying the recipe will take you. So this is also an output. If you want to read more about the notion of data maturity or fair maturity in the context of FAIR Plus, I invite you to have a look at this site. And part of the process of the editorial board when reviewing and performing the review of the content that you will produce is to set this maturity level, insert them. So the reason I mentioned this is simply because we we have this view of the recipe as well, which allow also to rank, present a view, ranked view of the different recipes, which allows a potential user to assemble a course as well and orient the investment to a particular level. You don't have to be fully fair necessarily. You can just choose the level of pain that you accept to tolerate. So now I'm finishing. Just a reminder of the different routes that you can choose to contribute. And yes, I think this is the end of the quick introduction for the how to contribute to the cookbook. We will value very much your input and your contribution. And if you see an OpenAI logo orbiting this distant world, you're not hallucinating completely. This is the case. So thank you very much. I will take any questions.
Thank you very much, Philippe, for this presentation of the FAIR Cookbook. It's a very interesting resource, so that's why we have considered it in our way of sharing the information, because mappings are essential for FAIR as well. I mean, it's part of the interoperability, but also improving findability. So everything that you presented was very interesting, and I hope that it will help people to actually have a better knowledge about the FAIR cookbook. I engage you to actually look at the resource. It's very good. And just to remind you, that is our goal at the end of the project, is that we get some mapping recipes for process. Is there any quick question for Philippe? Don't see. Baptiste?
Yes, thank you for the presentation. I was just wondering what was the discipline scope of that tool. Is it completely generic, so it can be applied, or at the moment, what is the scope and what is the goal scope?
Yeah, very good question. So the scope for the FAIR cookbook is there are two aspects. Mostly the content is about life sciences. So this is the where we were born to an extent. So life sciences applied to drug discovery. I think there is a bit of that. Not that strong, but I think it was the origin of the project through the collaboration with pharma industry. But as I indicated, we also collaborated with the plant community, and we are trying to reach out. So it would be interesting to see if there are other domains and you want to expand to show how you do verification in, say, aspect of physics, for instance. We could also accept these recipes, or and just to document the kind of vocabulary that are of interest to the community, to promote practice patterns, implementation patterns. I think the Go Fair called that implementation profiles. I think this is something important to highlight.
Thank you very much, Philippe and Baptiste, for the question. Now I would like to move to the next part of the session and start with the community presentations on mapping practices. And our first speaker is Isabelle Bernal from CSIC. CSIC, okay. Isabelle, the floor is yours.
Okay, thank you very much for this invitation. I think the workshop is super timely. Can you see my presentation?
Yes.
Yes. Okay. So I'm the manager of Open Science Services and the repository at the Research Council in Spain. But here I'm representing DataCite. I'm the co-chair of DataCite's metadata schema working group. And my focus on this presentation is going to be about the process we use to do mappings between DataCite and Dublin Core. So I would like to say first that there is a tradition from the very beginning of the working group to do mappings with other schemas. So from the very early versions of the schema, we've been doing mappings with DDI metadata schema and others that have been emerging and created over the last years. This is a work that is done in cooperation between DataCite staff and the metadata working group members. We are all volunteers representing our institutions in this working group. And one thing I want to stress here from the beginning is that we are always welcoming and promoting feedback from the broader community. At the very end of my presentation, you'll see a link and with all the channels that we've been promoting and opening mostly over the last years to get all the feedback, suggestions, ideas from the community. So if I focus on the specific mappings work between, from DataCite to Dublin Core schema, we've been doing this already from version 2 of DataCite metadata schema, and also for version 4.4 that was released a couple of years ago, we updated this mapping. We have two main motivations for this work. One is that many DataCite customers are still using Dublin Core schema on the repositories for many different reasons. We can have institutional policies, legacy reasons. Many repositories that started as publications repositories also started to deposit, manage research data. So they probably started as repositories using Dublin Core, and they incorporated DataCite. So we know this situation is quite common. So this is one of the main motivations to maintain and update these mappings, and also because these are two main discipline agnostic metadata schemas being used broadly. We have two new mappings that go together with version 4.5 of DataCite metadata schema. In fact, we are about to start a huge promotion of this. So also the workshop is very timely. So these two new mappings are the ones here. I mean, the links are accessible already. One is mapping to Dublin Core qualified, and the other one is a local DataCite Dublin Core extension we've done. This is the first time we try to do a local mapping to incorporate as many properties and subproperties that are specific to DataCite to be used on Dublin Core. So the goal of this work, of this mapping work, is to map as many DataCite properties and subproperties as possible. DataCite is very granular, the schema. As you all know, the beginning of the schema was concentrating on research data, but now is dealing with a very wide range of research outputs, and there are many properties and subproperties, mostly on this new 4.5 version. And as part of the process, one thing we do is to to do a landscape scan to identify standards, guidelines, recommendations that are being used by repositories that are using Dublin Core, because we are trying to propose mappings that are useful for the community. I could mention, for instance, that we have a close look to guidelines like OpenAir, but also controlled list and other recommendations used by the community. Of course, in this mapping work, somebody already said that this is a very labor-intensive work. We encounter challenges that probably are the same that you encounter in your mapping efforts. And I identified, or I listed some here. For instance, it is sometimes it happens that there's no exact match of semantics or usage amongst elements in the two schemas, elements that are slightly different in meaning or in usage in DataCite or Dublin Core. Or also we can find no corresponding values for specific attributes, no same controlled list that are linked to specific attributes in the schema. This, for instance, is the case with contributor type and relation type. Each schema, DataCite and Dublin Core, uses different values, controlled list. And also another challenge is how to handle when we are trying to map different DataCite properties and subproperties into the same Dublin Core elements, because we are going from a very granular schema to another schema where some subproperties or elements are missing. Another challenge that is worth mentioning here is how to map identifiers with respective agents. As you all know, persistent identifiers are really important in this whole FAIR landscape, and we found a solution for these two new mappings we have, and which is we are using the PID attribute that has been proposed by the Scholarly Resources Application Profile. This is an initiative led by the National Library of Finland, and is together with DCMI is looking into new terms for Dublin Core, and also for a solution to pack PIDs into the Dublin Core schema. So instead of reinventing the wheel, we are making use of this proposal in these two new mappings we are offering to you all. So besides challenges on the way, we also found many opportunities for collaboration. By doing this work, we realized that one, there are many local extensions of Dublin Core schema. This schema is still very, very intensively and widely used in the world, and there are many different local extensions to serve the purposes of every single repository. And also, there are other local and DataCite Dublin Core mappings out there. So this means that there is a huge community with experts on metadata mappings and with a lot of knowledge, and this is an opportunity for further collaboration. Also, another opportunity is how to tackle all these challenges, to pack persistent identifiers that are associated with more and more values in the schema. And another field where we see more and more need for collaboration is interoperability across different controlled vocabularies that are attached to different attributes in the schema. As I said, we are already for a number of years, we have a close collaboration with this initiative led by the National Library of Finland, which is building an application profile on Dublin Core to better describe research outputs. We are collaborating, participating in their working group, and also taking up their solutions and proposals, but this is not the only one, of course. So this is why this workshop is so timely to open other channels of collaboration. And I think we also have to engage the repository software communities so that there are functionalities and features in the code that enable and ease the adoption of all these metadata mapping. So, because as we all know, it's very labor intensive to do all these mappings and to enable them by yourself. And I like to finalize again showing you this link. As I said, we are really encouraging, promoting, welcoming all feedback about not only the schema, the metadata schema per se, but also about these mappings. So please, if you have time over the next days, have a look and send us through any of the proposed channels all your ideas, suggestions for improvements. So thank you very much.
Thank you, Isabel, for this presentation.
Mm-hmm.
Any quick question for Isabel, where we're setting up the next talk, which will be given by Sam. Sam, do you mind?
Maybe I have one question, because I know a lot about these crosswalks and mappings, because I have done also the same things for all schemas, for how I say 15 schemas, different. Also data site has been one. Problem is the loss of semantics. If you transfer, for example, if you transfer geolocation point to DC coverage spatial, you lose semantics, but also problem is how to define this string in Dublin Core, because if you have only a point, for example, you have problems. Also, you have different types of descriptions in Dublin Core. It's hard to do things because also the other problem is if you want to convert from Dublin Core to data site schema. This is not real mappings. This is my opinion.
So thank you, Milan. So I answer very quickly. So these two new mappings that we've done, I really invite you to go through them. So as I said, one of them is mapping to Dublin Core qualified. So this means that we only mapped to Dublin Core elements that are existing. So in this mapping, we are not making any extension. The only extension we've done in the two new mappings is to incorporate this proposal from the scholarly resources outputs application profile to package PIDs. So this is something that is coming from the Dublin Core community. And it's only on the second mapping, on the local data site Dublin Core extension, where we've tried to incorporate specific data sites properties and sub-properties into Dublin Core. So of course there is a challenge because you are going from a very granular schema to a less granular schema. But I mean, this is why we are all here, because we are discussing all the challenges about doing all this.
Problem is that this Dublin Core local extension is not exist. Nobody used this. So this is a big challenge, how to achieve that somebody will use this Dublin Core.
I have to apologize, Milan, but we need to keep it short because there's 6 more presentations to go.
Yes, yes.
We're already a bit late, so if we want to have some time for discussions in the breakout, I think we need to move on. So I'm sorry, Baptiste, you know you raised your hand. Maybe if you can keep your question for later. Now I would like to invite Sam Le Franc to actually present the mapping process in Disco. Sam?
Hi, can you see my screen?
Yes.
Yeah, thank you. Thanks for inviting for inviting me. Yeah, okay. Yeah, I'm representing the TETWIC, which is the Organization for Biodiversity Standard, and DISCO, another acronym, which is the Distributed System for Scientific Collections. We're looking at natural history collections. And yeah, I've been working on mapping data standards for MIDS, and MIDS stands for the minimal information about the digital specimen. So in the, this is this task group within the Biodiversity Information Standard. We fall under the collection description. So our main aim is to describe collections. That's the interest group, and it's being led and pulled forward by Elspeth Hastings from the Royal Botanical Garden in Edinburgh, and Kat Chapman from IDIC Bio. Now, a bit of background on what's the aim of what we're trying to do. We're really trying to measure the completeness of the specimen information. So we have a lot of specimens in our natural history collections. We have billions of specimens in our natural history collections. And with DISCO, we're trying to make an effort on further digitalize these specimens. DISCO is then focused on Europe in particular. So we want to at least have a baseline on how much of the specimen information is, what's the level of the current specimen information, and where do we want to go to, and which steps can we take. So it's really about measuring and monitoring the digitalization effort. So I've already put here some schema. You see that most of the specimen information currently is at level 0, a couple is at level 1, and we then have level 2, which only I think is hit by the data set we have tested with about 2 million records. And only 200 hit the MIDS level 2. And 3 is then the goal of the digitally extended specimen, the DES. Well, MIDS helps in the measuring and monitoring this process. It also guides for the prioritization. So if we can, on a collection level and on a broader level, easily see what the status is of the collections at the moment, we can also see which groups are underrepresented. Maybe there are groups that there's some more priority that are red list species that we really need to focus on getting the data completeness in our systems up. We want to align this with the existing mass digitalization programs so that they can also focus, and we have now identified the most important aspects, the most important data information elements of these of this specimen information, that these mass digitalization programs can focus on those. We want to provide a mapping, and this is where we're focused on the next couple of slides, to help with the implementation of the calculation of MIDS. So from the task group, we want to provide a mapping to existing data standards so that systems can easily measure the MIDS level. And the MIDS level is aimed at data completeness, and we will provide recommendations for data quality as well, but data quality is really the next step after the MIDS levels, as with the data completeness. We have identified 4 levels, which is really the basis, which is really, I can identify a specimen to, there's some basic information there, which helps. And MIDS level 2 is more the who, what, where was it collected, who collected it, and what is it precisely. And 3 is then the digital expanded specimen, where we make links to other data sources. Yeah, important is that MIDS has information elements, and these information elements are about completeness of data quality. And I've put a list about them here on the right with MIDS level 1, where you have things as name, specimen type, object type, modified, and license. And these are really generic. With MIDS, we're not trying to create an additional data standard. There are already a lot of different data standards in the biodiversity realm. What we really try to do is create a measurement. So we're not creating another ontology. We really have elements. We wanted to have a name in there, and that could be a number of different attributes in other data standards. And that's why this mapping is so essential for us, because we want the mapping against multiple of these data standards. Mainly the main, we will focus initially on the main bigger ones, the ones that are being maintained by the biodiversity data standards community, the TEDWIC community. It's really important that we have the same miscalculation on all of the, using the same mapping on all over the places, because we expect that MIDs will be calculated on an institutional level, but can also be calculated on a data aggregator level. So there are different places where MIDs will be calculated. And yeah, it would be a pity if in the first calculation on your institutional level, you would reach a higher MIDs level than the data aggregator, where they might use a different mapping and you would get a lower MIDs level. So what we have started to look at is to create a simple standard of sharing ontological mappings, the SSSOM. It has been mentioned already, mainly because there was another group within our realm of biodiversity standards, which has quite successful created this mapping, and we want to see if we can follow that path and do a similar process. And initially we focused on the simple knowledge organization system, the SCOS ontology for doing the mappings. So we created a mapping for each of the MIDS information elements. And I put an example here. So here we have the physical specimen ID. I don't know, yeah, if I can show the mouse, but we have a physical specimen ID, which is part of MIDS level 0. And this has a narrow match to a material sample ID. But here, so basically what this means, what we're trying to say here, and that's up for discussion if we're doing it the right way, but what we're trying to say here, if there's any value in the material sample ID, or in the catalog number, or in an attribute from Darwin Core, which is called other catalog numbers, or any of these other fields that we mentioned here on the right side, if there's any value in one of these fields, then you comply to this element in MIDS, to the physical specimen ID. Yeah, we've tried to create these against the main data standards. We now have over 200 of these individual mappings against 9 different data standards, and we'll probably grow further. We started it because none of us had experience in this realm. None of us had experience in the data mapping realm. So we tried to create from 7 different places and combine these. And so we're building on top of the work of Matthias Dille and Elsbeth and myself. So what were some of the challenges that we ran into and that we might be able to discuss today? So we're not really mapping between 2 data standards. We're really mapping between information elements and data standards. And it sometimes seems that that's not as easy as if you're doing 2 data standards. I'm not sure if this completely works for us, so that's a bit of the question still. We get tricky things where, for example, if we have one MIDS element, which is called the quantitative location, it requires the presence of 3 different data standard elements. So let's say if we map it again to this Darwin Core field, there's one information element in MIDS maps to 3 information elements in the data standard. So quantitative location here maps against the decimal latitude. So if we want to have the location and you comply for that location of the specimen, we need at least to have a latitude, a longitude, and the geodic datum, which is the system that's being used. So all these 3 things need to be present before you comply. So with SCOS, we had some difficulty. So I've been looking at other ontologies as well. This is one we came across which might be interested. So this is an experiment that we're currently doing. And then we're also looking, could we do it another way, which is at the bottom here. We said this is the intersection of, and then provide for this one mapping, for this one element, provide some additional information saying, well, it is part of this set of attributes that it needs to comply to. So we use the pipe here to create this enumeration. So our question is a bit: has anybody looked at this on how to create these and or relationships, or are we now a bit working against the SSOM mapping? And is there then another way to indicate this? Are there other ontologies that we could have a look at? And then another issue that we'll probably reach in the future is that, you know, we now want to perform this standard against different civilization formats. Are there tools already in that place? Are we really, and what are the best practices in providing this mapping for both human and machine usage? So we're really newcomers in this field, and but it is really interesting to see what's already happening, and we're really interested in the outcomes of this task, and see how we can include it in our work and create this mapping process.
Thank you, Sam.
Yeah, thanks.
Sorry to interrupt. Okay, so I would propose that we move forward to the next. So I will invite Alexandra and Gwenaël. Sorry about that, Sam, but we'll manage discussion. I think one of the, I mean, your presentation highlights a specific use case, and that would be actually very interesting to discuss your problem in the second part of the work. So here we're talking about the practical aspect, and it's nice because you introduced us with the process you set up in this work. But the questions that you have, technical questions, are indeed very relevant for the second part.
Yeah, very good.
SSOM does not cover everything, so it's a good answer for simple things, but for a bit more complex things, it doesn't work. Alexandra, Gwenaël, could you?
I will make the presentation. We wrote it together.
Okay.
So I'll start sharing. I think I can. Can you see my screen?
Not yet.
Oh, okay.
Perfect. Good.
Okay, brilliant. Thank you. So good morning, everyone. I'm Alexandra Kokinaki from the National Oceanography Centre, the British Oceanographic Data Centre in the UK. And I will present mappings in the marine domain, use cases, practices, standards, and governance. We call it the NERC vocabulary server with my colleague Gwen Moncoife. And we start with the NERC vocabulary server, as this is the semantic repository for standardized hierarchical terminologies used for the management of data in the marine and related domains. We represent and we publish our vocabularies as linked data using SCOS, and that's why you will see that NVS stores and shares vocabularies, also called collections or SCOS collections, including terms, concepts, and relationships, also called mappings, between terms in a human and machine readable format. The backbones of NVS is its strong governance. There is a vocabulary management group that supports and drives NVS, and of course a big community that co-creates with us what NVS publishes. The publication process that we have, publishing the vocabularies in many different ways, like Sparkle, SOAP, REST APIs. The standards we follow that are mainly linked open data. We have complemented NVS with tools, and we monitor all of our services. Going to the questions of this workshop, as we said, because we publish in SCOS, we keep our mappings. We also provide our mappings in SCOS core. So we provide hierarchical mappings using the SCOS broader and SCOS narrower, and some associative using SCOS related, and one borrowed from OWL, the OWL same as. But as time went on, we wanted to express our mappings in a more qualified way, having more expressive mappings. And that's why we adapted different other ontologies, like the iAdapt, the PUV, parameter usage vocabulary, and the QUDT that I will talk a little bit in the next slides. The types of mappings we do are different in the way that you can see them. So this is, for example, a concept in NVS. It's coming from the data storage units of BODC. This one is the dimensionless unit. And you can see that we have internal mappings. So we map from NVS concepts to NVS concepts, but we also have external mappings, for example, mapping to DBpedia or CH vocabularies. So external concepts that belong to external vocabularies. We also, as we said, have hierarchical relationships like the SCOS broader and associative ones. And then we also have the more expressive relationships coming from these three different ontologies. This is a concept that is scoring high in the granularity scale and is an observable property, quite detailed. And because it is detailed, it's difficult to actually maintain. So in order to maintain it, we have a semantic model behind it. And that semantic model creates the labels of this kind of concepts by concatenating the labels of other atomic concepts. And this semantic model is expressed as mappings underneath. And you will show how this is the concentration of the oxygen per unit volume of the water body. When we started, we expressed, many years ago, these mappings were expressed quite generically as broaders and relateds. And we've always had this wish to actually use more qualified relationships, but also be interoperable and standardized with what we're doing. And that's why we now in NVS, we have profiles. So we publish the same thing using different properties. For example, we have this iAdapt profile, and we use the iAdapt ontology to express the same thing with different terms or properties. So this concentration here is that this concept has property concentration. This concept has as object of interest the oxygen, and it also has as matrix the water body. And that's a more qualified and expressive way of associating our concept with its atomic concepts. Now, mappings are actually expressed as part of the concept definition. So it's not separate to the concept, but it's part. So this is a turtle expression of a concept. We show all of its metadata and data. So what type it is, what's its definition, preferred label, and all of that. But we also show the broader and the related and the mappings inside the concept itself. This is how mappings look like in NVS. And we capture for each one of our mappings the subject. So what we are mapping, the relationship and the object, who made it, when, and we also have a unique URI per mapping, and we also capture the status of the mapping. So as we said, because we have a unique mapping for our URIs, this is how a mapping looks like. So it says this mapping has this URI, the subject is this particular concept, it is the same as that concept, it was made at that time, it is valid, and it was made by that person. And this is how the machine readable view of that mapping looks like. And as you will see, we use SESOM properties to describe our mappings. And we also, one of the next steps we want to do is to reduce this verbose expression of who made the mapping by using ORCIDs instead of this big expression of who made the mapping. Now, some of the questions that were asked is, how do you decide something needs to be mapped? And we decide that something needs to be mapped because it will facilitate discovery of concepts and data, because we have to do semantic modeling of our complex concepts. So we have to do that these mappings because it will help interoperability. So for example, adapting the I-adapt vocabularies or mapping to external vocabularies, manage hierarchies and associations. So you have to map if you have hierarchies, and also create mappings based on use case requirements. When we make mappings, the considerations we have are, there are some mappings that are mandatory. And if we don't make them, we leave orphans in the hierarchies. So for example, every high granularity P01 term must be mapped to a lower granularity P02, and we can only map to one of them. So this is a mandatory rule. There are other considerations that are part of our workflows when we create content, and they support interoperability. For example, for each, there are mappings to external registers, for example, KEBI and WORMS, and we have to do them. And some others are more opportunistic. So ad hoc mappings when an easy equivalence with partner resources is found. For example, mapping of our biological subcomponents or chemical entities to ICs. And the difference between why do we do systematic or opportunistic mappings is mainly driven by the use case and the funding or lack of it. The curation, maintenance, and governance processes in NVS is that our mappings are actually stored in an audited relational database, and the maintenance is actually checking the integrity and the correctness of them is created through constraints, triggers, and procedures. Our mappings can be withdrawn or deprecated if they are invalid or redundant. Now, why a mapping can become invalid is maybe a concept from a term from an external vocabulary no longer exists, or they may be erroneous. Our users and our community can create, edit, or deprecate mappings of their own vocabularies using a tool that we have, the vocab editor, but also users can suggest and request mappings via the GitHub repository where what we have for NVS. Do I have any more time, or should I stop here?
No, sorry, Alexandra.
Yeah, I'm okay. I knew that, so I'm happy to stop here.
Thank you. Now our next presentation will be James McLaughlin from OLS. James.
Hello.
Hello, welcome.
Let me just share screen. Sorry, I'm just trying to get the presenter view to work. Hello, so I'm James McLaughlin. I'm from EBI, and I'm responsible for a lot of the stuff we do with ontologies, including mappings. So we host and manage some big biomedical databases like Ensemble, Uniprot, and the GVOS catalog. We also provide various ontology tools that you might have heard of, like the ontology lookup service, OLS, OXO, which is an ontology mapping tool, Zoomer for string-to-term mappings, and more recently, we've been developing a new tool called OnToString, which is a semi-automated curation tool. So lots of our data is annotated using ontology terms. We have an application ontology called the experimental factor ontology, which imports terms from various domain ontologies, and that gets used to annotate our data sets by curators and various different web services. So we've got lots of use cases for mappings. There's lots of direct overlap in the ontology ecosystem. So for example, for disease ontologies, there's both DOID and Mondo. And in that case, there's lots of different terms which represent exactly the same thing. And in order to make data sets comparable, we need to align them. But then there's also less obvious overlap. So things like disease phenotype association might be a direct mapping, or it might be a mapping from a disease to a group of phenotypes, for example. And then, but the most important thing about mappings for us is that they could be scientifically interesting. So, for example, if you map from mouse phenotypes to human phenotypes, then you can make two data sets from different species comparable. So an example of how we use mappings across our different data sets and ontologies. So this diagram consists of both mappings and correspondences and associations. So you can see in the bottom right we have only a laser pointer really, but we have the oh, can you see my mouse?
Yes, we can see your mouse.
Yep.
Oh, okay. So for example, the mouse phenotype and the human phenotype correspond to each other. And the way that we design our ontologies means that often we don't even need to map these. So for example, with MP and HP, which is the mammalian phenotype and the human phenotype ontologies, we define these using the EQ model, which means that the ontology terms are, the reasoner can actually assert that these ontology terms are the same. So we're gradually trying to move more towards this model. So rather than defining everything lexically and then having to build mappings up afterwards, we try and define things in with lots of ontological rigor and let the reasoner figure out that they're the same. However, it's not always that easy, and lots of explicitly defined mappings have been created over the years. Ontologies often define them, especially using the oboe and owl has dbxref predicate, which means simultaneously everything and nothing. So this is an example in the ontology lookup service showing a term and the different terms that it maps to, and we've resolved these using the bioregistry now to turn them into clickable links. But the main problem, as I'm sure most of you know, is that these mappings, has dbxref doesn't actually have any semantics associated with it. So this could be any kind of correspondence or association. So we are gradually trying to externalize mappings rather than store them in ontologies, because you might want to make mappings between vocabularies you didn't develop. Also because you might want to use richer descriptions of mappings. So we're moving things towards SSOM and the SEMAPV vocabulary, and that allows you to attach a lot more metadata to mappings and make them more useful. And also mappings are subjective, so the same vocabularies can be mapped in different ways depending on which approaches you use or who you are and what you want to map things to. So we're also part of the Mapping Commons organization on GitHub, which has, that's where the SSOM standard is maintained. And also we're trying to build data sets there, publicly available data sets of mappings represented in TSV format. So hopefully this will become a really nice resource for open source mappings. And for example, we're extracting all of the mappings that are already in ontologies, we're putting them into SSOM format and uploading that to uploading that to the organization. So I think people have already spoken about SSOM, so I won't describe it too much, but it's essentially this TSV format, but it's semantically well defined. So it's accessible to bioinformaticians who are used to working with tabular formats, but also it's linked into the semantic web world through the LinkML definitions. So we also provide the OXO tool, which I'm sure some of you are familiar with. It's an API and web interface to access mappings. We're currently developing a new version of OXO, which will be built on the SSOM data model to improve its interoperability. But OXO allows you to search using a RESTful API. You can get back different terms, and also it's built on a graph database, so you can do multiple hops out from a term. So you can do transitive mappings. But transitive mappings can be problematic if the mappings aren't well defined. But how do we define the mappings in the first place? So we've got various different methodologies. So manual curation is the most accurate, but also it's very time consuming and expensive. And the idea there is that you get an expert in the subject matter to look at the sets of terms, go through them and say, yeah, these are the same. But then you can also use, and I think what probably gets overused is lexical matching, which is where you literally look at what labels are similar strings. Then there are semantic similarity methods like Jacquard, where you look at the semantic overlap of the terms and how they're defined in ontologies. And then lots of different combined approaches. So what tends to get done by most of the teams at EBI who are doing curation is some kind of semi-automated mapping approach where they combine automated approaches with manual approaches. So it's a supervised automated approach. And then LLMs, obviously the elephant in the room. We're looking into using them. We're trying out some work from one of our collaborators, MapperGPT, and seeing if that can help. But that comes with its own risks, and we need to be careful not to inject hallucinations from Reddit into our carefully curated scientific data sets. So mappings can be correspondences. There are different kinds of correspondences. So things like Scott exact match and ALD equivalent class are direct correspondences. And then there are more fuzzy correspondences, which can be things like gene codes for protein, because the gene and the protein aren't the same thing. But if we didn't make them map to each other, we wouldn't get any work done. And then associations are very different from mappings, and we need to be careful, I think, that as we try and define what mappings are, we don't let the scope creep go too far and reinvent OWL and the entire ontology world using our mapping technology. So I think it's important to create that distinction between correspondence and associations. And also I wanted to mention string to term mappings. So term to term mappings is where you have two ontology defined terms or database identifiers and you map them to each other. But another important class of mappings is string to term. So it might be that you have a free text string and you want to map it to an ontology identifier. And these kind of mappings are really important for extracting ontology terms from bodies of text. And then a lot of data sets that especially in our case, that arrive at EBI are written in free text. It could be like you've got a column with lots of names of diseases or body parts that you want to map the terms. And also string to term mappings can be highly contextual because the same string may map to a different term depending on your context. In a lot of we've got a slide that goes around our presentations, which is where there's a picture of has been for about a decade, I think, where there's a picture of a jaguar and it's like, is it a car or is it a big cat?
Sorry to interrupt, James, just minutes left.
Yeah. How many minutes?
1.
Oh, that's fine. So yeah, we've added a new profile to SSOM to represent these string to term mappings, which will help to open up some of the data that we have in our string to term mapping repositories, because we generate a lot of this data at EBI. So we're gradually publishing that data on GitHub. We've got a tool, Zoomer, for string to term mappings, which we're exporting to SSOM. And we're also developing a new tool onto string, which for semi-automated curation of string to term mappings. So I just wanted to give string to term mappings some love in this talk because I think they're often overlooked. So yeah, to conclude, we use mappings extensively to link to biomedical data sets. We're trying to move from explicit mappings to semantic equivalence. We're looking at using LLMs, and yeah, we're aggressively adopting SSOM. I think Are we doing questions at the end of all of these talks?
No, unfortunately not, because we're already too late. So if
I will respond to them in the chat then. Okay.
Yeah, questions can be in the chat or in the note document, right? Sorry to be a bit too restrictive on communication. Thank you very much, James, for this presentation. Next in line is Simon Jupp from SciByte. Simon, floor is yours.
Yeah, hi, thank you. Am I sharing the right screen?
Yep.
Okay, good. Okay, morning everyone. Yeah, so I'm from SciBite. We're a software technology company within Elsevier, mainly developing tools for working with ontologies, large-scale data annotation, and more recently tools for doing ontology mappings at scale. So I think, we're all here because we have a good understanding of the problem, but we know that the ontology landscape is complex. There's a lot of different standards, overlapping standards, and I think we really sort of have to accept that we need mappings to embrace this mess. We're not going to standardize around a couple of common standards, so that kind of acceptance and that mappings are sort of crucial for large-scale interoperability, and that's why we need to build good tools for both generating and managing these kind of often complex mapping sets. So I think James just teed this slide up nicely because the first thing to say, especially in kind of the sort of pharmaceutical space that we work in, and a lot of the terminologies and vocabularies that people are using, there's already very good coverage if you actually look at it. So when OXO was first built, it was really to try and expose those kind of public mapping sets, which are really good, and to try and sort of use the sort of crowdsourcing of lots of public mappings to say, look, when there's really strong overlap, then we can be pretty confident that these mappings are all a pretty high quality, irrespective of the semantics of DBXref. So there's this kind of subset of mappings where we know that the quality is good, and what we actually want to focus on is the sort of the long tail where the mappings become a bit more ambiguous, and the areas where we have very little coverage between ontologies. So in addition to the kind of more sort of Wild West of public mappings, there's also some really high quality reference mapping sets. So if you know where to go, there are curated mapping sets, and we can, again, we should be building on these because they actually, when you start to look at the concepts in here, the synonyms that they have, we actually have a really good background knowledge of data that we should be using when we're trying to predict and generate new mappings. So, there's a whole host of challenges, and it's great that this workshop's here now so we can start to sort of categorize these challenges. But so the first one is about looking and finding good sets of mappings that are already existing. So making sure that people aren't just having to sort of reinvent the wheel when we have good alignment for certain areas of disease and things like that. There's a significant challenge in then just normalizing these public mappings, and I think this really points to things like SOSOM as a standard to actually help us normalize how these mappings are published, what formats they're published in, what kind of identifier, ways that different groups are representing identifiers. That alone can be, a significant headache where you might have two good reference mapping sets, but they're just in completely different formats, and they've just use slightly different identifier schemes, even though the identifiers are essentially the same. And these are just sort of, hurdles to just, that people have to work through when you're kind of pulling these mappings together. Again, with SOSOM, I think, everyone's recognizing that we need a bit more provenance around the quality of mappings. And it's great that we've got a standard now, and it's great to hear that people are sort of aligning on those standards for publishing the mappings that they have. And then one thing I'm going to talk a little bit more about today is just, when you're building custom mappings. So especially with a lot of the organizations that we work with, the big pharma companies, they're switched on to, FAIR, and they want to get access to all the public mapping sets. But they also have a large internal sort of legacy of data. So mapping between internal custom standards that have been developed across different departments and through mergers and acquisitions and stuff to the public standards. There's a real need for tools to help manage those mappings at scale, and those things have versions and they need governance in terms of how people can access, and depending on which different groups are accessing those mappings, they'll want different views across those mappings. Something else that James was touching on, and I wanted to, at a very high level. So there are different tools around that help us to do predicted mappings. So there's kind of two broad categories where we have sort of rule-based approaches. So this is looking at, lexical mapping, and this can get you quite far, especially when areas where we have good coverage, good synonym coverage. You can do quite well just looking at label and string similarity. And then there's tools like LogMap that actually give you a bit more. So starting to think a bit more about like the structure of the ontologies and the semantics that are already there, and can we use those to help us infer new types of mappings. And then there's definitely lots of like good literature coming out now, and tools becoming available where they're taking more sort of machine learning approaches. Tools like BertMap and just heard about MapperGPT, looking at these kind of alternate approaches. And I think there's a lot of tools out there and there's a lot of approaches, and none of these are kind of a single going to give you a kind of good 100% alignment. So what we generally find is that you need to use a combination of approaches for predicting mappings, and it's really that there needs to be a human in the loop. So these tools are good at generating candidates and they're good at kind of scoring the confidence, but it's really important that you have that kind of curation step, and that's one of the things that we've been focusing on at SciBite, is building tools to kind of support that human in the loop when you have these tools for generating large amounts of predicted alignments. So some of the challenges that we see with the kind of open source tools, a lot of them are sort of pretty cumbersome to either run and set up. They don't tend to scale very well. If you're trying to align two very large ontologies, you may struggle to kind of run these tools just on your own laptop. And like I say, there's a lack of emphasis on the curation and the maintenance of those mappings. So you can sort of generally generate one large alignment, and then the curation tends to happen, maybe in Excel, and a lot of the sort of decision making is kind of lost. And as we've heard before, again, there's sort of there's subtlety, right, in the life sciences especially, and we often really need to capture that kind of context and decision making that goes into curating mappings. So we do a whole host of this at SciBite, and it's a combination, like I say, of approaches. We pull in a lot of those public mappings. We pull in the mappings from OXO. It's a great sort of public resource for us. And then we kind of enrich that with reciprocal mappings, our own internal curation. We do a lot of cleanup just on the identifiers, so aligning on query prefixes, so that that we can spot very obvious mappings, even if they've used slightly different ways to represent the identifier. And then obviously we have our own internal tooling that we can use to actually predict and generate mappings. So something that we've just launched this year, it's a new product, is called SciBite Workbench. And this is a platform and sort of web UI for generating large amount of mappings at scale. So it runs using SciBite's name density recognition technology, and also is starting to bring in public and curated sources to allow sort of biocurators a very simple way to just generate an alignment between two sets of vocabularies or ontologies. And the important thing is that the these mappings are scored, and the curator is
Simon, 1 minute.
1 minute, that's fine.
Thanks.
And one thing I wanted to talk about maybe later in the breakouts is this idea of using mediating vocabularies, this idea of building on existing mappings. And we do a lot of this with SciBite Workbench, where we use kind of background knowledge to infer new mappings based on kind of this crosswalking public kind of well-curated mappings. And yeah, I think I can try and wrap up quickly here then. So yeah, we've got this tool. I think that this is something that's missing in the sort of public domain, is a real kind of user-friendly tool for bioinformaticians to actually just generate mappings and not have to worry about doing the installation and making sure that then you can get these mappings out. So we support export in the SASOM format. So once you've done that curation in Workbench, you can get that data out and take it off to wherever it needs to go. Whether it's publishing in these kind of public ontology lookup services. So I just rushed at the end, but I've kind of hopefully got
sorry.
No, it's fine. I think you get the gist.
Thank you, Simon. So if you have questions to Simon, please use the chat or the notes. Now I would like to move to the next talk. Alain Monteil from INRIA will talk about AL. Alain?
Good morning. Do you see my screen?
Yes.
So I hope I'll be very quickly because everybody wants to have a coffee break. Until now, we have a lot of speakers speaking about mapping, and I will speak about crosswalk. And this presentation is made with the help of Moran Krenputer from Software Heritage and Yannick Barberini from CCSD, who is the developer of AL. Oh, sorry. One more. No. I lose my mouse. Oh. Yeah. So this presentation is a brief presentation of CodeMeta, then CodeMeta crosswalk, and after last the meta crosswalk for AL. CodeMeta is a specific schema based on schema.org to describe the software source code. And it's an initiative beginning in 2020, if I well remember. It is an academic initiative, and there is a GitHub repo and a site web. I put the link here. It's you can go after to this GitHub CodeMeta, and you can participate. It's open to everybody. Actually, the crosswalk for CodeMeta is an individual initiative from people. There is no governance. There is no metadata to describe the crosswalk we did, or we will do, and there is no README. So it is a CSV file available on GitHub, and as I said, some are not yet done as the Blinker, but maybe I have to discuss with Isabel, the first speaker, because she worked on the Blinker, so maybe we have an opportunity to work together to make the crosswalk between CodeMeta and the Blinker. In a specific context, in the Faircore for European project, there is a work package 6. I don't know if Moran is online, but in this context, there is some crosswork made to make an API to connect software heritage to different platforms, to a scholarly repository with Invenio RDM and Dataverse, to publishers, Dashtool and API Science. It's not in reality CSD. Aggregators with SWMAT and OpenAir. So now I will speak what we did around CodeMeta, Crosswalk, and AL. AL, for people who don't know what it is a French repository for researchers to put publications, but also source code. We began to work on this issue in 2017 with software heritage to make the possibility to describe source code in AL and related to the code which is archived on software heritage. So for that, we use the CodeMeta schema, and the good point for using CodeMeta and the good point for CodeMeta basing on schema.org, there is a lot of field which is compliant with any with schema.org, and it is sharing with other items in HAL like publication, articles, or communication, or and so on. There is some specific metadata for source code. I put here some example with the code repository. It is a link to GitHub, for example, the license of the source code, the operating system, the language of programmation, and all this metadata is based also on CodeMeta, and some of them are proposed to schema.org to become a new field on schema.org. So why we need crosswalk in this context on HAL and CodeMeta and source code? The first need is to have to increase citation and interoperability and findable and reusable of the source code which are described on HAL and are available on the software heritage. So it is very important to have the CodeMeta format to export from HAL for this item. The second reason to have this crosswalk is to build a new services and a facility for researchers to describe directly the source code with the SWID. The SWID is the identifier available from the software heritage. And then the researcher put the SWID with CodeMeta. There is a extraction of a metadata field, and it's very easy for researchers to make the describe of the source code. For that, we use a CSV file, and we have a column for CodeMeta properties, a column for all fields, and because we need it in HAL and finally in Big Tech export, we make also a column for XML TEI correspondence and the Big Tech correspondence. In also, we have new fields created for the CodeMeta, as I said, code repository, license, operating system, and programmation language. And we extend new properties from existing field, and particularly for author. And there is new role for this author, designer, maintainer. This role is very important to credit people who are engaged in the development of software. For the license, we use a new referential SPDX licenses. So it's very important to use a same language for source code because it is common with the other system or other repository. I hope you see that it's the CodeMeta coming from HAL, and as just you see, you have the identifier of HAL, and you just add /CodeMeta to have this on your screen, and this is the user or the web presentation of this software. Sorry, now I have to go back to my presentation. Oh, how do I do that?
Maybe if you try Alt-Tab.
Yeah. No, I haven't seen my tabs. Doesn't matter because I think I have finished. Yeah. So to make this crosswalk, we have some hackathon between experts. And so the Yannick Barberini, the developer of HAL, Moran Krenpeter from Software Heritage, and Estelle Niveau, Josefina Sadowska, and I, librarians from INRIA. For one case, we need an expert. It is Roberto Di Cosmo, the founders of Software Heritage, to make to make the choice when we have the questions and we are not agree in the expert area. The benefits of this coursework is, as I said, it's shared with ePScience because ePScience is also a CCSD application. So in the Faircore for IOSC work package, it was very easy to make the services to allow to make a connector between ePScience and software heritage. But this coursework, there is no governance for maintaining, updating the mapping, sorry. This mapping is only used in our system for some minimal required fields, and it's not directly available. So this coursework is not very fair. Next step for this coursework, we have to discuss around the evolution of CodeMeta to the version 3. We have to finalize the coursework for XML/TI and after that, the RDF format of all items, and include more CodeMeta fields like funder or is part of, because all field is not already done in the coursework. And finally, and it's why it is very important for us to listen what you said around the mapping. We have the objective to make this CodeMeta coursework more fair. So we need some metadata like title, ID, author, description, and to see what is possible with SESAM or something to make mapping with other vocabulary. Thank you for listening.
Well,
if you have any question, there is the mail. We are behind this mail. There is Moran, I, and Yannick Barberini. Thank you.
thank you, Alain, for this presentation. So last presentation is Linda. So Linda Reynaud, I hope I pronounce it well. Is
Fair
Linda?
enough. Yeah, so I hope you can see the screen.
Yep.
Yeah, so listening to all your presentations, I feel a bit as the odd one out, because we were not talking about the ontologies when we did our mapping, but we were migrating our digital archive from one system to the next. Oh, I have to do it like that. So I work at DANS. It has a digital archive. It has data sets and files that is archived and being disseminated. And we were migrating from our own system that we built ourselves to a Dataverse, which is a off-the-shelf open source system for the same solution. So we went from one repository where we had a lot of different data sets to 4 different data stations based on the different communities. Based on the content of our repository, we chose these 4. And the work of the past years have been about doing the actual migration. So what we did is we had 2 different stores. We had Easy, which is the web-facing part, and we had a dark archive, which has it's an archival solution for data from parties that don't want us to disseminate it, but want us to store it securely. So both of them we want in the end to be through this data station. So we had to find a solution to get them through the same pipeline. So actually we made 3 different mappings. The first one is this layer where we put them into the same structure, which is based on Baggett. And then we did the major part was done in the transform, where we cleaned all the data and we made sure that we can easily ingest it in the next mapping. So this transform was the bulk of the work, where we looked for controlled vocabularies to use for keywords, to clean up the data, to find better ways to do geospatial points and boxes. And the final mapping was a very straightforward mapping from our internal schema to the Dataverse schema. So what were our considerations on doing this if we look at the process of it? So we wanted 100% coverage, so all the metadata that was in the original should also be in the target. And we wanted to keep the original so that you can always refer back to what was actually deposited at the beginning. And also to show what kind of changes we made if we added terms to it, if we cleaned up keywords, stuff like that. We wanted to keep a change set for that. Easy was our own system, so we were very flexible with it. We could do whatever fields we wanted to add, we could add it. But Dataverse is a off-the-shelf system, so it was fixed in that sense. So there were some flexibilities, so you could use, you can add new fields to it, but then of course you are no longer completely compatible with the other Dataverses that are out there, so you want to minimize that. And we also added some stuff to the core, some concepts that were not yet there, like embargo on files that wasn't there yet. So we wanted to include it because for us it's really important, because a lot of files in our system are embargoed for until a certain date. So the kind of transformations that we did was mainly text to term, as it was called before, finding controlled vocabularies that were aligning with what we are actually doing. So one of our main data stations is the archaeology. It is a large part of our content is archaeological data. So we looked for controlled vocabularies in this domain and did text to term for that on in this transformation step. Another big, because we have all the data at hand and it was a finite set and we know everything that's in there, we could do a lot of analysis on it. So also there were free text fields like a notes field or other description fields. So we could actually analyze what was in there and on a per data set base, more or less, decide where to put it in the target scheme. That was a huge advantage of having everything already known before you start with the task. Another reason that we wanted to do it in these 3 different steps is that we will also still use this ingest for data sets that come in later from third-party data providers. So we can use the same process in that scenario as well. And I wanted to say something about file accessibility, which was a huge problem for us, but I don't know if it's so interesting for this audience, but for us it was very interesting because we had a very flexible method of saying which file is accessible to whom. And in the target system, this was not so flexible. So you could not, in one data set, have both files that are closed and files that are restricted. So we needed to find a solution on how to deal with that. So for us, it was a huge mapping problem, but it's not really an ontology mapping issue. And I wanted to say really quick something about another project that we were doing at DANS, which is the Odyssey portal, where we get data from different data providers and map it also to the Dataverse internal scheme. And this is done by a separate team, and they created a small software to help them with this, which was called a Dataverse mapper, where you can add your own mapping and create it and use it to create a Dataverse compatible ingest ready metadata file. That's within the time limit.
Thank you, Linda, for this presentation. Indeed, it's a bit different from what we had before, but this is still mappings, data mappings and transformation. It's also a topic, and it's interesting to see what are the problems and the process you can use to actually perform this data mapping. So this concludes our community presentation session. We're a bit late. I would propose that we go for a quick bio break and reconvene at noon. So it's 11:50. So let's take 10 minutes to, for a break, and then we'll move to the breakout sessions at noon.
That is an example of that. I'm not going to repeat what I missed. We'll just have to go with it. And versus one-to-one mappings. So quite a lot of the presentations, some went to a mediating authority and some did one-to-ones. And they're two legitimate schools, so we must incorporate those in our frameworks. The third is that there are many communities all doing mappings, and it will be useful if their impact produced some sort of community directory of the activities that are ongoing and their locus of interest and focus, so that people would know where to go for information. And the fourth is to really define what we mean by a mapping in a pragmatic kind of way, in order to be able to separate out things that are to do with equivalence versus things which are properties of, say, the concepts that you're mapping against. So otherwise you might end up trying to bring in all sorts of other properties rather than trying to keep on track to the notion of an equivalence between different concepts. Though that equivalence will be very rich. It could be pragmatic, it could be semantic, it can be structural. There are all sorts of different interpretations. And we should avoid entering new ontology wars when discussing that. So we need to keep it very simple and straightforward. And that's it. That's our 4 points.
Okay, great. So for our group, we talked about stages, and we talked a lot about the pre-mapping stage, actually, the kind of considerations, what needs to be mapped, why it's being mapped. And we played a little bit with the diagram, and we fed in that you have like source documents, output documents, and then the stakeholders who'd be involved in that. We talked a little bit about CEDA, which is converting DCAT into kind of non-PDF fairer views. We talked about granularity. I think same as you, Carol, talked about the granularity of mapping, what's being mapped exactly, what level of detail, how you express that, and how to evaluate that afterwards. We talked about types of mapping, as in whether you do something at the level that it's fit for purpose for your use case, and whether you want just the best mapping you can, or you want just coverage. So the considerations, the balance you have to strike, kind of like that cost benefit kind of analysis, and whether that's something that we could kind of document somehow, whether we can express those things that you should think about. Deciding reference ontologies, we said, was very, very important because you can't map everything to everything. So try and identify some key ones. We talked about importing, not recreating things, but rather importing things. We talked a little bit about EFO, and we talked about automated mapping processes where you have communities or users who would decide whether something is accepted or not, and how to express that quality. I think that's, we didn't do very well on the diagram, but we made some notes.
I don't think the diagrams matter at the point.
Yeah.
It's
yeah.
not, doesn't really matter.
Yeah. Okay. So
that's a bit. Oh, sorry.
Yeah. So let's move on to the third breakout, which was Maria.
Well, she did do a diagram.
Yeah, I was going to say that was a pity that the diagrams don't matter, because we did a lot of progress on the diagram, and also we choose Jacob as a spokesperson. So
yeah, so after some struggle with the diagram software, we collaborated creating this output, and we tried to visualize the whole process, how mappings are done. So first decide on the vocabularies, identify some concepts which are most important to map, and then check whether there are the important question in the middle, are there mappings, checks whether some existing mappings can be reused. But each time if there is a mapping, it also needs to be evaluated, because often they come from other projects that have other requirements. And yeah, in the best case, it can be reused, and sometimes the format needs to be adapted, but then it can directly be used in applications or converted to CSM format or other format that is needed. And in the best case, we can give feedback to the existing repository where the mapping is located. But often there are no mappings, so the right branch, then we need to find some matching candidates for mappings, and there are several tools to do so listed here. And these candidates are evaluated, and one step is deciding on the mapping relation. And after that, we can produce the mapping set in a defined format and upload this to to a repository or directly use an application. So this is very general workflow, but I think it captures the important parts.
Looks very nice. Okay, I think Alejandra, you were the fourth breakout group moderator.
Yeah, that's right. So yeah, we mainly had a discussion. So there are lots of notes in the document, and the main points that we took are the importance of the context of the mappings, and especially the ultimate use case. So documenting that use case is critical, but not only like, for example, I want to do data integration, but what is this data integration going to be used for? Very different mappings if we do data integration or interoperability between systems, for example, and we did go into a bit of the detail at different levels of mappings and considering the schemas versus mapping concepts, etc. It was really clear that mappings are a means to an end, and that end is what we agreed that we need to document well. In terms of tools and resources, everyone agreed that the most common tool being used is mappings are being done in Excel. Some people are using lexical mappings, and we talk about the importance of confidence levels, so that mappings, that mappings are an iterative, results of an iterative approach, and we may have different candidate mapping sets, and they will have different confidence levels if they were done manually or used some tools. Usually the tools are lexical mapping, so looking at the string similarity or equivalence. And we kind of agree that there are semantically aware tools, but they are usually difficult to use and to understand the results, so people are not using them so much. We talked a lot about the predicates, and again, in the pre-mapping phase, some people may choose a pre-selection of predicates, depending, again, the use case should be driving the predicates to be used. And we discuss about the difference between correspondences and associations, and how these, again, depending on the use case, may be more relevant one or the other. And in terms of the review process, we talked about involving experts when necessary, especially if the mapping is complex. And that's a high level of the points we discuss, I think. But yeah, anyone else from the group, feel free to add something that I may have missed. There is a small diagram that Nico started on the Miro board as well. So yeah, we'll put all of these together then for the notes.
I've just cut and pasted that diagram into the notes.
Great, thank you.
Just in case we lose Miro for some reason. Great, Yann.
Yeah. I think there's some common themes, right? Especially at the pre-mapping, I thought, and the review and quality.
Yeah, and it seems that no one complained about the 4-step process so far, or even enriched it. So it means that at least we can have a generic backbone process with these 4 steps. And then the interesting things is that things were focused in the different discussions on either describing the full process, which is great work on breakout 3, I guess. Thank you, Jakob, for presenting that. I mean, it's interesting to see the real practical steps. And then there were details on different aspects of each of the process that needs to be covered and considered. So I think that we can now reconcile these things and, refine the list of questions based on the discussions we just had.
I particularly was taken in our breakout on the agile development methodology, and I think that's also worth having as a bigger framing, because I think that's really relevant. So contribution models, how do you maintain things, how do you come to agreement, because there's a bigger picture there, as well as the dealing with the tasks, specific tasks. So I think it's going to be a sort of modularized approach, as one would expect.
I see Nico raised a hand. Nico?
Yeah, just for your 4-phase model, I think that the way that I would describe it, or at least a term that is also linked to this agile methodology that I would use a bit more strongly, is that we need to define a process that is strictly iterative, because we need to deal with change. We need to deal with sources and target spaces are changing. Decisions are changing, errors are found by users, and so on. So the fact that this is a living artifact that needs to be maintained, versioned, identified in its own rights, and that this is just a continuous refinement cycle is one of the important changes in thought that we need to take, because right now the world is kind of more focused on, like, here's the mapping, drop it somewhere, and that's that. And then maybe the next generation will find it in later, but I think iteration is really key here.
Yeah, I agree with that analysis, and that's what we discussed in our group as well, the agility and the process. We didn't touch the governance and how you maintain them over time, but I think this workshop was quite successful, because we did have an overview of all the problems with the presentations. And again, I would like to thank all the presenters that actually contributed to that session, really enriching. Now the next step for us is to start analyzing, of course, the outcomes of that discussions, but there would be a second workshop which we would plan more really work session rather than presentation workshop. And the idea is now to deep dive into the different elements that we unearthed in the breakout room to actually come up with a sort of a more generic framework and take into account all the bits and pieces that we just discussed today. Because the ultimate objective of this series of the workshop is to come up with a sort of well-described recipe process that can be shared for, communities that didn't start, or even community that have their own process, but it's not, it's very simple and basic. So I think we can stop here. I would like to thank you all for contributing to that workshop. It was really great to have these 3 hours talking about mappings again. I would like to thank all the speakers again. Really appreciate your effort and trying to keep up with the time and so on, although we had some jitter, that's normal. And thank you for your contribution in the breakout rooms. And I would like to thank also the organizers, Carol, Nick, Yana, Sarah for taking care of the Zoom. And we will actually be sending out some information about the survey for collecting even more inputs or practical inputs on specific questions. So, please follow up on the Fair Impact website and the news. And we'll let you know when we are going to organize our next workshop rather soon, I hope. Well, if my colleagues do not have anything else to add, I would like to say, wish you a good end of Friday and a good weekend.
And thank you to everybody who contributed fantastic talks.
Really.
The materials are wonderful.
Right.
Yeah. Thank you, everyone.
And join us at the next workshop.
Thank you.
Thanks,
Thank
everyone.
you.
Start
you.
working.
Bye.
Bye.
Thanks,
Bye.
Bye.
Thank you.
Bye.